Welcome Pure Maths 1 students to our maintenance course for the Pure Maths 1 course. The purpose of this course is to revise as we go through the year studying our Pure Maths, to go back over topics that we've already covered so that when it comes to exam time there's not so much need for cramming, because you've been regularly going back over some of the topics and skills that you've covered earlier in the year and last year. So what I want to do is produce videos for these for each week, and I would like you, in the maintenance booklet that I have given you, to work through the weeks ahead of time and then come to these videos and go over them as a form of revision and marking. So where you went wrong, slow things down, have a look at how I've done it. And if you've got questions, you can put a comment on the video or message me through ThinkWave. Because the teaching time that I have with you this year in Pure Maths classes is enough to get you by to in terms of covering the chapters in the textbook. But if you really want to excel and get an A or a B in the course, you're going to need to be doing work on your own. Not just in the teaching time that I have with you. It's not like IGCSE, so I really want you to understand that this course will require you to do a lot of independent work, and that's why I've given you this big thick maintenance booklet, and we're going to go through it a week at a time. So make sure you're getting every week you want to do one of the week's homework sections in the maintenance booklet. You want to do that on your own, and then you want to check on these videos, and they'll come out each week at the same time, so you can do this in your own time and have a look at it for homework, and then contact me with any questions. Okay, it's really important that you don't just rely on what we do in class time. Otherwise, some of you will probably fail, and others of you won't be able to get the results that you want. It's really important that you are doing work on your own. Probably at least 2 or 3 hours a week of extra work needs to go into this course if you want to excel in terms of plus the teaching time that I have with you, which I think is about 3 hours teaching time. It's just not enough. So also you want to be doing this and watching these videos and other videos that I've got on my Pure Maths 1 channel as well. Okay, well, with that lengthy introduction, we're going to get into it. Last year we looked at quadratics a little bit. So this first one here, we've got to solve this equation. It's a inequality. Now I'm just going to see, can I actually, yes I can. So I'm going to try factorizing. If you can factorize, it's always a good idea to do that. So I'm going to go x plus 4 bracket x plus 3 is less than or equal to 0. And then at this point I know that what my roots are. Oh, that's a bit dodgy. I'm not used to using this. It's been a while. So I've got a root at, let's say, -3 and a root at -4. I really need to get used to this, don't I? And okay, and it'll look something like this. Now we want to know the bits of this which are less than or equal to 0. And you can see that it's this bit here between those two numbers, -4 and -3. So what we would say then is -4 is less than or equal to x is less than or equal to -3, and that's the way that we say it's within that range. Okay, minimum -4, maximum -3, and all of the values between those two integers will be less than 0 when you plug them into the formula, and you can check that out if you like on your calculator. Okay, I'm going to just make this a bit bigger so we can see a little bit better. Okay, so this next one, we've got to solve this equation by completing the square. So my first step is I want to get rid of this 3 in front here. So I'm going to factorize that out for the first two terms. So you can see there, if I multiply out that square bracket, then I'd get 3x squared plus 12x. And I'll just park this plus 2 outside my square brackets. And then my next step would be within the square brackets to complete the square. So I'm going to have x plus 2 all squared. And then to make up for the fact that when I use FOIL on this, I'd get a plus 4 at the end, right? Because last times last, 2 times 2 is 4. I've got to subtract that 4. And I put my square bracket around here. So if I expand that, I would expand this, then I would get this here. Okay? And then, of course, that plus 2 there. Then I'm going to expand out my square brackets. So I get 3 into x plus 2 all squared minus 12 plus 2 equals 0. So I should get 3 into x plus 2 all squared. That's minus 10 equals 0. Now I'm going to start bringing stuff across to the other side. So my next line, I could probably go 3 into x plus 2 all squared is equal to, and I move that minus 10 across to get a positive 10. I'm now going to just do my working up on this line here. So I'm going up there, okay. Whoops. What's going on? We've got some... Okay, never mind. So we get x plus 2 all squared is equal to 10 over 3, because I'm dividing both sides by that 3 that was in front of the brackets. Then I'm going to take the square root of both sides. So I'm going to get plus or minus the square root of 10 over 3. And then I bring that plus 2 across by making it a minus 2. So I've got minus 2 plus or minus the square root of 10 over 3. Okay, so that's the second one complete. Now the next one in your booklet is this one here. We've got to solve giving exact answers. So we're wanting surds there. Surds are when we've got, instead of writing it as, to 3 significant figures, we might write, in this last one, what did we have? Minus 2 plus the square root of 10 over 3 was one of the answers, right? This is a surd. So we write in, we want the full answer, full accurate answer. Whoops, I think I just deleted something there. Whoops. Okay. Things aren't working very well here, or I'm just a bit hazy with the program. I haven't used it since last year. Now what I do with these ones, you see, it's a little bit different from a quadratic, but in some ways similar. So we could say that y equals is equal to x squared. And then we could rewrite this equation. So obviously the minus 4x squared would be minus 4y. And then we could replace this with y squared. Okay, so I hope you can see what we've done there. And then we could, what could we do here? Actually, I think we can just factorize at this point. Yeah, y minus 7 and positive 3, yeah. There we go. And so we'd get y is equal to, in the first bracket, to make things equal to 0 would be 7 or minus 3. Now, at this point, you've got to remember the substitution that you did earlier. So if we substitute y equals to x squared, to get x, we're going to take the square root of y. Therefore, x is equal to square root plus or minus square root 7 or plus or minus square root minus 3. Now we can ignore this solution because we just want real answers at this stage. In Pure Maths 3 we talk about complex numbers and that sort of thing, but we're not going to worry about that today. Okay, so we get plus or minus square root 7 would be the answer. There we go. The next one is a simultaneous equation. Now, well, we know in terms of y what each thing is there, so my first step would be to write 2x squared plus 1 equals 4x plus 7, and then we're going to form a quadratic equation by bringing everything over to the left hand side. So I get minus 4x, And then when I take that 7 across, it becomes minus 7. So minus 7 plus 1 is minus 6 equals 0. Then you can see that all of the coefficients and this minus 6 here are divisible by 2. So I'm going to divide everything by 2. And that gives me that. And then I can factorize, and I'm thinking minus 3 and plus 1, and therefore x is equal to 3 or minus 1. Now it's a simultaneous equation, so we need to find out what y is. Therefore, y equals, now I'm going to plug it, I'm just going to plug the two values into this one here. So if I plug a 3 in, 4 times 3 is 12, and plus 7 is 19. And if I plug in the minus 1, it's negative 4, 4 times negative 1, and then plus 7, which is 3. So our solutions are when x is 3, so 3 comma 19, that's where those two functions would cross, and minus 1 comma 3 if we're doing the coordinates where they plot meet. Okay, now moving on to functions. So that was some quadratics-y kind of stuff. Now moving on to functions. We've got to find the range of this following function. Now, one of the ways, the main way that you'll be finding ranges of functions is to find the minimum point. Now, with a graph like this, if you know your quadratics, all that has happened is, you know, and normally would have an x squared graph, and it would be like this, right? And a 2x squared is just steeper, so it'll be like this, right? Even steeper. And then this minus 3 just drops it down to crossing point here. Okay, so it's going to look roughly like this. Okay, and that's minus 3 there. Now, given that we're going between minus 3, which is somewhere out here, say, and positive 1, which is over here, so say, we know that our minimum point is at the minus 3. It doesn't go any lower than that. And we want to know how high it goes. Okay, so you can kind of tell that it's going to be highest at minus 3, not 1, but you can plug them in. So 2 times 1 squared minus 3 equals minus 1, or 2 times minus 3 squared minus 3. Now minus 3 squared is 9, 2 times 9 is 18, take away 3 is 15. So your values, the lowest value you have is here, okay, minus 3, and the highest you have is going to be up here at positive 15, and you're going, the values that you're allowed are all the way through to here, which is where 1 is. Okay, so to write that as a range, we're going to say, what are we going to say? Lowest value, minus 3, is less than or equal to fx is less than or equal to 15. I think that should be it. For some reason, when I did this previously, I wrote it down wrong. Unless I've just had a brain fade and made a mistake here. So the second question I've had to redo because I didn't read the question properly. We've got this function. It's defined, and I believe that we should have x does not equal 0 as part of our domain. X is a member of a set of real numbers, but x does not equal 0. Now what I'm going to do is create the composite function by inserting x minus 1 over x into so that becomes my x, and I'm inserting in my composite function. So I'm going to make that first thing equal to minus 2, and then everywhere that there is an x, I'm going to write x minus 1 all over x. So x minus 1 over x minus 1 all over, and then x minus 1 over x. So you see, so that x minus 1 over x on top is that x, and on the bottom that replaces the x. So you see we've created a composite function, and that's equal to minus 2. Okay. Now I'm going to rewrite that so that it's got a denominator of x. So I can just have x minus 1 all over x, and then minus 1 becomes minus x all over x, right? Because minus x over x is minus 1. So that's what I've done there, and then on the bottom I've still got the same thing. Okay, so that's how we get to that step. Now what I'm going to do is I'll be left with minus 1 over x, because x minus x is 0. And then that will be all over x minus 1 over x. Now what I do at this point is I could rewrite that as a division, you know, your fractions. So I write it like this, and then I could multiply by the reciprocal. And what you see is that those x's cancel out. So I can do that here and be left with minus 1 over x minus 1. Okay? Now, oh, look, yeah, they're all equal to negative 2. So, not 2, negative 2. Yeah, just write in negative 2 there and there. Whoops. 2. Okay, right, there we go. And then I'm going to multiply both sides by x minus 1. So I'll get that. That shouldn't be minus 2, it's times by minus 2. So I expand that out and I get minus 1 equals minus 2x plus 2. I'm just going to do a little bit of rearranging here. So 2x minus equals 3, because I'm going to bring that 2 across the other side, and then times both minus 1. So we get x equals negative 3, equals 3 over 2. Now, let's have a look at this next one. Find an expression for the inverse of this function here. So we've got a function. We know that x can't equal 1, obviously, because we can't have a 0 at the bottom of that fraction. Otherwise, we'd have undefined, right? Anything divided by 0 is undefined. So my first step is I'm just going to write it as y is equal to 2 plus 1 over, oh, let's get rid of that nonsense, 1 minus x. Then I'm going to swap my x's and y's, because that's what an inverse does. You're swapping your input and your output. Now I'm going to rearrange and solve for x, y being my subject. So I'd get this. I'm going to get that 1 minus y across by multiplying both sides by it. And I'd have x minus 2. That's an x there, by the way. That's looking rather horrific. Okay, like that. And then I'll divide that across the other side, so I get this. Then what I'll do is I'll move the y to the right by adding it, and move this fraction to the left by subtracting it, right? So that would give me y equals 1 minus 1 over x minus 2. Just think about what I've done there. Hope that makes sense. So I brought this over here by subtracting it, and I brought this over here by adding it. Okay? Now, and then the last step is to write that in function notation. So inverse function is equal to 1 minus 1 over x minus 2. And I've got to state its domain. Well, the domain of this is equal to the range of the function. Remember we chatted about this last year when we were doing functions. The domain of the original function is the range of the inverse, and the range of the inverse becomes the domain. Sorry, the range of the original function becomes the domain of the inverse. Okay, so they just swap over because the x's and y's swap over, obviously. Okay, now if we were to think about this here when we're plotting it, what we'd get is something like this. There's going to be like this sort of scenario going on. And you'll have this sort of asymptote here, and it'll approach both that and this. Now, this x value here is 1. Okay, because x can never equal 1. And then the y value is 2. Right, because no matter what you have here, it's always going to, if you're adding up an x value and a negative x value on the bottom, it's always going to be slightly above 2, because you're adding this fraction on. Or if you just put in a positive x value above 1, it's always going to be just it's going to be below 2. Okay, so that's what that graph will look like, which means, what do we know about our range of this? Our range of the original function is anything, okay, because it will go down, 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 down here, down, and then up, 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 up here. The only thing it can't be is 2. So that's our range. So therefore our domain, where our input is x, is a member of the set of real numbers, but x cannot be equal to 2. If you're a bit hazy about how to graph these type functions, have a chat to me and I'll give you some. There should be some information else in your IGCSE textbooks if you've still got those. I think that is all for today. Yeah, it is all for today. I hope that's been helpful to you, and of course send your questions through. Let me know if you're having trouble with these. Alright, take care team, see ya.